Hello everyone, my name is Morteza Bashsiz. I am a Linux system engineer. At this series of videos, you are going to find out how to be a good Linux system engineer. So if you want to know, stay with me.
Welcome to LSE episode 5. At this episode, I am going to talk about the conceptual points of IP and port. What is IP, what kind of IPs we have, and also what are the classes in IP version 4 and the relation between IP and port and how they are defined. So let's start it. So what we have here at this episode. At this episode, we are here. You can see the overview, the previous topics and the next topics that we are going to talk about them. And what is IP? IP is abbreviation of Internet Protocol, which is a unique identifier, pointer or address for a device in a network. As a brief description that what is a network? Network is a union of devices that are connected together with network interface and cables and the others in a simple sentence. So if we have some devices that they are connected together with network devices, they are building a network. So if a device wants to connect and interact with another devices over network, it must have a network interface controller, and each network interface controller must have a MAC address, which is the physical address of the network interface. And also a network interface must have at least one IP to be able to have interaction and to connect with the other nodes in a network. And this IP is unique in network. And for example, we have IP number 1 for this node, 2, 3, 4, and 5. Okay. Imagine that these are IPs and the IPs are unique, and if we have another node, okay, with the same IP, for example, this is 2, and it will be in conflict with this node, and this is not correct. So IP must be unique in a network, could not be duplicated, and this is unique. There is two types of IPs, version 4 and version 6. In version 4 we have 4 parts separated by dot. In version 6 we have 6 parts, usually separated by colon, same as MAC address. In version 4 these parts are containing integers from 0 to 255, and in IP version 6 we have hexadecimal characters, 4 hexadecimal characters in each part, and IP version 4 is limited. IP version 6 is limited too, but the count of IP at this system is too much, and you will not imagine how it could be finished. But IP version 4 is limited, and we faced with restriction in using IP version 4, and IP version 4 is not enough for all the devices in all over of the world. And we are not talking about IP version 6 at this episode. We will talk about version 4 at this episode. So we have here each part in version 4 called octet. This is an example of IP version 4. Each part called octet. Why? Because of the 8 bits available at each part. So why octet? We have mono, D, tri, tetra, penta, hexa, hepta, and octa. So this is the reason that we called octet. So IP version 4 contains 4 octet, and in each octet we have 8 bits to define the integer. Let's talk about how a binary system works. In binary system, we have only 0 or 1 and nothing else. And also we have some bits that you can put 0 or 1 in them. And for example, we have 4 bits. Imagine that we have 4 bits, and this is an example. For example, at the first bit we have 2 in power of 0, 2 power of 1, 2 power 2, and 2 power 3, and 2 power blah 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 blah. It will continue. And when you put 1 in each bit, okay, that bit will be enabled, it will be calculated. And when you put 0, the bit will be disabled and will not calculated. Okay, so as an example, if we have 1 0 1 0, what does it mean? It means that here we have 2 power of 3, 8. It will not be calculated, so this is 0. It will be calculated. 2 power of 1 is 2. It will not be calculated. So this is 10. Or in another example, we have here these. So we don't care about them because 0 is not calculated and the bits are disabled. But here we have an 8 and also plus 2 power of 2, 4, which is 12. And in another example, if we have like this, we don't care about them. We have 2 power of 0 here, 2 power of 1, and then it will be 2 plus 1, 3. So with binary numbers, you are able to build all the integers. And why we are talking about the binary model of numbers? Because it will help us to better understanding the IP and how IPs are defined and what is the structure of IP. And this is the reason that we show the IPs in binary mode. Generally, we have 2 main categories for IP. A IP is public or private. A public IP is accessible over the internet. The private IP is not accessible over the internet and it is just used for local usage. And yeah, this is the differences between public and private. Based on what we talked here till now, the first IP in IP version 4 is 1.0.0.0. Okay, and the last IP is 255, 255. The maximum number that could be in octet, 255, 255. Okay, and this is the last IP, But it does not mean that you can use all the IPs between these two IP in your network interface. And there are some specifications like network IP or broadcast IP that we will talk about them later. And you cannot use these IPs in your network interface controller. And it depends to your networking, to your subnetting. And we will cover these topics in next videos. And yeah, this is the definition of IP and IP version 4 specific. In IP version 4, we have 5 classes: A, B, C, D, E. And you can see at this table the first IP in each class and last IP in each class. And this is the reason that I write them in binary, which you can see the differences between classes and how the classes are defined. Here, this bit is fixed in class A, and the others are between from 0 to all 1. And yeah, this is class B. These 2 bits are fixed, and for class C, these are fixed, and for class D, these are fixed, and also for E. So in each octet, we have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have here 2 power of 0, 2 power of 1, 2, 3, 4, 5, 6, 7. The first octet could not be completely 0 because you will not find IP start with 0. And like this, for example. Like this. And for an octet, this is not the first octet, I'm just talking about the binary system. The minimum number is when we have all 0 here. Okay, and all the bits are disabled, and the minimum is, and the maximum amount is when we have 1 in all of them. So this is completely 0, and for this we have 2 power of 0, 1 here, 2 power of 1, 2 power of 2, 2 power of 3, 8, 2 power of 4, 16, 2 power of 5, 2 power of 6, and 2 power of 7, which could be this number. So these are the definitions of classes in IP version 4, and you can see why and what is the differences between class A and B. They are separated based on these fixed bits in the structure of IP. And in class A, from IP version 4, we have 2 ranges that are public and 1 range that is private. And this is only in class A, the loopback range. We will talk about them, don't worry. Yeah, in class A, the first available IP in public range is this, and the last one is this. And this is the biggest private range in IP version 4 that are used usually in intranet in big networks, that we have a lot of nodes and a lot of devices in our network. And also we have another public range, and yeah, loopback is for loopback interface, and we will talk about it later. And good to know that we have a big issue. It's not issue, but yeah, it could be like a bug, I don't know. But we have a huge amount of IPs just for loopback, and loopback IPs are not usable in network interfaces. But okay, you can use them, but there is no reason. And yeah, you have to touch a lot of things in your routing tables and the others things to be routable in your network. But yeah, you can see that how many IPs are wasted at this range. In class B, the same. We have two public range and one private range. This private is smaller than in class A, and yeah, this private range is used in middle size of network. When there is not too much IPs in your infrastructure, this is okay for you using this range as a private network. And in class C, the same. We have two public range and also a private range that you can see. And this range is the mostly used and most famous range in IP version 4. And yeah, this is the default range in all home type access points and home type routers and devices. And what about class D and class E? These classes are not usable and they are not used in everywhere. For example, class D is not used in a host as an IP address for interface, and they are used for multicasting. And again, no worry about what is multicasting. Just keep in mind, we will talk about it in next episodes. So class D is used for multicasting, and this is not usable in network interface controller. And also the same for class E, it's not usable in your network interface, and this range is for special purposes and not available in general use case. And for example, these IPs are reserved for research and special purpose. And what is port? The port is a logical communication endpoint over the IP address, which can be used in networking to define the source and the destination. Let me describe it with an example. Imagine we have a company which is internet service provider. Okay, this is the building of company. Yeah. And this is the smoke. Yeah, this company provides internet for the customers. We have customers here, and also there are a lot of agents which are responsible for supporting the customers. Customers faced with an issue, and they call the support number of the company, for example, the telephone number of support of the internet service is 2525, and they call these numbers. And for example, we have some agents here. This is agent 53, this is agent 173, and this is agent 85. Okay, and this is customer 1, customer A, customer B, customer C. Customer A called this number and wants to talk with his or her agent, and okay, the telephony system, the IVR menu, says that you called the number 2525, and this is the support and customer care service. Enter your agent's internal number, and yeah, customer A dialed 53, and then it connects to the correct agent, and the same number B dialed, and he entered the internal number of agent 85 and connects, and also the same for agent C, which is connects to agent 173. Okay, at this example, this is the phone number is IP, exactly the IP, which is unique and directly points to the host. The ISP is host. Okay, the phone number is IP, and the internal numbers are ports. So easy. So we have a host here. Let's describe it with a real example. We have a host here, which there are three main services on it. A service provides web, a service provides database, service provides SSH for secure shell. And we are here, and you are a system engineer and wants to SSH to this server. At this host, SSH is listening on port 22, web is listening on port 80, and DB is listening on port 3306. Okay, if you want to, and the host IP address is, for example, this. And you want to reach to the service SSH on this host. So you specify the port in your command line. Okay, and you want to reach to the web server and get the service of web from this host. You specify the port, and here usually the normal way to defining the IP and port is with colon IP colon port. Okay, and there is no rule, there is no must to specify ports to processes and services, but there is a standard. Okay, and there is defaults. For example, in web, all the browsers by default for HTTP are using port 880 here. This is a default behavior in your browser. And also for HTTPS, the default port is 443. You can, of course, you can configure your web service to listen on port 80, for example 53 instead of 80, but in your browser, when you want to when you want to reach to the service that listens to this port instead of 80, you have to specify port. For example, HTTP domain colon and not default port. But when you don't enter and specify the port, by default it will use 80 for it. Or for example for DNS, for mail server, for telnet, for SSH, for FTP. These are services names and you will introduce with them. You can use every port that you want, but these are standards and these are defaults. It is better to use the correct port on your service. And so we have a limitation on ports. Ports are available from 0 to this number, 65, 535. But the port 0 is not usable everywhere. You cannot use port 0 when your connection is over TCP, but in specific situations UDP is usable in UDP connection, but totally you will not see anything on, in normal situation you will not see anything on port 0. And from this range, from 0 up to 1024, this port range is for the main processes in your operating system, and it's not recommended to use less than this port for your user level applications. For example, you may heard about that for securing your SSH connection, they changed the port from 22 to, for example, to 20 or 22, or a port or a random port like this. And they think that by changing the port, your service, your SSH service is more secure, but this is not correct. This is completely false. You will see why this is completely false, and because the SSH is main process, and this is not good to bind the service to some ports upper than 1024 because of this reason, and we will talk about them, why this is not correct. And we are done here. Thank you so much for watching this episode. If you liked it, please to support me, subscribe to the channel and also share the video with your friends. See you in next episode. Bye.